What's up, guys? It's Dr. Hyman back on your screens once more. Why chit chat when we can get into it? Okay, today we're looking at two very similar reactions. We're going to look at the Castro-Stevens and the Sonogashira reaction. Both of these reactions are copper mediated, which we'll take a look at in a moment with our reagents. However, the Sonogashira reaction is palladium catalyzed, so we'll see a similarity to some of the other organometallic reaction mechanisms we've done this far. We'll have an oxidative addition, a transmetallation, and then we'll have a reductive elimination. So fun. So both of these reactions can occur with an aryl or a vinyl halide coupled with an alkyl or an aryl terminal alkene. However, the Castro-Stevens will likely use an iodide or a bromide, while the Sonogashira can use an iodide, a triflate or bromide, and sometimes a chloride. The Sonogashira reaction also has some more possibilities for the R group as opposed to the alkyl or the aryl substitution, and there's also a possibility of hetero-aryl halides reacting as well. One thing that's special about the Castro-Stevens is that it has the possibility of forming heterocyclic products using either alcohols or amine groups ortho to the halide, ortho to the aryl halide. Let's take a look at our reactions. So, if we take a look at the first reaction under the Castro-Stevens and the Sonogashira title, we can see that we have the same reactants and end up achieving the exact same product. However, the only difference between these two reactions are the reagents used. In the Sonogashira reaction, we use that palladium catalyst as well as the copper iodide, but in the Castro-Stevens, we only end up using the copper iodide and not the palladium catalyst. Some other differences that can occur here are the halides used, as well as the R group is coming off of the terminal alkene, specifically in the Sonogashira reaction, which we discussed earlier. And then for the Castro-Stevens, we can see what happens when we have an alcohol or an amine group ortho to the halide. We end up with a heterocyclic product, and we can number the carbons from the alkene in our product so we can see where they line up. And then we can also look at our mechanism for the Sonogashira reaction, in which we start with the oxidative addition, adding in that palladium 0, and that first reactant, and then our transmetallation, adding in that second reactant, and then we have the reductive elimination, which returns our palladium 0 and gives us our product. Let's go over some examples. Yay. Also, the copper would end up associating here to the side of the alkyne and then going in for the transmetallation. Try out this practice problem. And there's our answer. Thank you guys for watching. Dr. Hyman has left the building.